In this video, we're going to look at ASCII and Unicode and understand, well, what do they do, what's the purpose of ASCII and Unicode, and then have a look at some exam questions as well, both on paper 1 and paper 2, to give you an idea of how ASCII can be applied to the GCSE exam, really. So the first thing is understanding what is the difference, what is ASCII and what is Unicode. So the way to remember it is that, basically computers only work in zeros and ones. We know that already, but zeros and ones are not the best for humans to understand. So what we have is something known as character sets, okay? What character sets are basically codes which relate to letters of the alphabet. So in a computer system, there'll be lots of character sets stored which represent, all the letters of the alphabet, A, B, C, D, and so on, all the different numeric numbers, 1, 2, 3, 4, 5, symbols and shapes such as question marks, percentage symbols, all that is stored inside the computer, and it knows that when I press a certain key on the keyboard, for example, it can turn that into a ASCII or Unicode equivalent, and then the computer knows how to turn that into binary, basically. It's a very basic way of understanding it, but that's ultimately how it is. So generally speaking, from ASCII, the lowercase letter a, for example, or uppercase in this case, main uppercase, is normally number 65, okay? Which therefore means that capital B is normally 66, C is 67, and so on. And then lowercase characters as well. I'm just going to mix it with lowercase. A is 97, B is 98. Let me do a lowercase. 98, C is 99, and so on. Okay, so uppercase and lowercase also have their own kind of numeric values as well. Okay, so a computer knows that letter capital A is represented as number 65, which can then be converted into its binary equivalent, and then lowercase a is 97. Okay, now you don't need to remember these. This is normally given to you in the exam if you need to actually use binary numbers, which we'll come to in this question down here in a moment. So on the paper 2 paper, the general kind of questions you'll get asked is about, well, what's the advantage of using Unicode over ASCII, or what are the main differences? So just to explain a little bit more about the two, really. So ASCII uses 7 bits, okay? So if you imagine kind of our binary table, which I can draw here for you. So if I just quickly draw that out, so let's do it by 8 bits. I'll put it here so we can fit on the screen. So we've got a binary table 1, 2, 4, 8, 16, 32, and 64, and 128. So if you imagine 7 bits, which is these bits here, okay, these are our 7 bits which are used for ASCII. Okay, if all of these were true, so if 1, 1, 1, 1, they were all true, and you added them all together, so 64 plus 32 plus 16 and so on, you would get 127, okay? So there's 127 different combinations there. But also, you've got to remember that if they're all zeros as well, so 0, 0, 0, and so on, that's also a combination, okay? That also acts as one different combination. So if you kind of change these zeros and ones, you find out there are 7 bits used, which means there are 128 different combinations of characters. Okay, so in ASCII, we can represent 128 different characters. That could be uppercase letters, lowercase letters, numbers, symbols, you name it. And for the English language, that was fine. Okay, because our English alphabet only has 26 letters. It isn't a big deal really for the UK anyway. To make use of these symbols, okay, it works fine for us. So that's why. Just to let you know, the 8th bit is used for error checking in ASCII, but as for GCSE curriculum, you don't need to worry about that, okay? The other option though is Unicode. Now, obviously, 128 characters works well for the UK, but it doesn't work well for other countries like, the Chinese language or the Japanese language, which have a wider range of characters for their languages. So Unicode is used instead, and Unicode is actually based on hexadecimal. And you don't need to know the ins and outs, but in Unicode, there are over 65,000 different combinations can be used. Okay, so you can make use of way more characters and symbols, which generally means it covers like multiple languages in Unicode. Okay, so there's loads and loads of languages that you can use. So you'll probably find the British kind of UK symbols will be in there. You'll have some Chinese symbols in there and lots of others. So a lot of the time, Unicode is kind of a all for one, one fits all kind of method because it covers all different languages and symbols and whatnot. Okay. So the kind of question you might get in the exam is state one advantage of using Unicode over ASCII. It might say state one advantage and then one disadvantage of using Unicode. So I'm going to explain those to you now. Okay. So the main advantages of using Unicode over ASCII is it can represent a wider range of symbols or a wider range of characters. So e.g. different languages or has a wider character set, any of those are appropriate for that kind of answer there. Okay, so wide range of symbol characters, that's basically it. Okay, Unicode has more characters, therefore it's better. Okay, the only real disadvantage to using Unicode over ASCII really is due to the wider range of character set. So due to more characters, more storage is required. And that's the only real downside to that really, is that you require more storage to store those extra characters because there's over 65,000 of them as opposed to ASCII, which only has 128. So obviously it's going to take up more storage, but let's be honest, kind of today's day and age of computers, it's not going to be that big a deal. So in this kind of question you ever get, if you ever ask for an advantage of Unicode over ASCII, it can represent a wider range of characters. Whereas in Unicode, the only downside is it just takes up more storage. But you never get asked the other way around. You never get asked what's the benefit of ASCII over Unicode, or if you do, it hasn't come up yet. So that's the kind of standard paper 2 question you'll get on Unicode and ASCII. This is a paper 1 style question. This is just talking about how ASCII values can generally be used and understanding it. So this talks about a subroutine, which is called code to char, which turns a numeric value, such as 97, into its ASCII equivalent, which in this case is lowercase a, which we've already talked about. Again, you don't need to know this, you don't need to revise these, it's purely just given to you in the exam. And obviously 65 gives us the uppercase A. So what happens is code to char, you enter a numeric value, e.g. 97, and it gives you a character back. And then char to code, it does the opposite. You enter a character and it gives you the numeric value back of that ASCII equivalence. So that's basically it, okay? Oh, just a note as well, with ASCII, in Unicode, with ASCII as part of Unicode, it's also got the same numbers. So even if this is using ASCII or Unicode, it's always going to be 97. So this question asked, shade one lozenge to show what value would be returned from the subroutine called code to char 100. So these types of questions, it's just a counting game. So we know that code to char 97 gives us A. So 97 equals A, which means 98 must equal B, 99 must equal C, which therefore means 100 then must equal lowercase d. It's always important to remember that if it gives you a choice of uppercase and lowercase, you have to be very careful with what you write down. So shade in the lozenge there, because you will get an incorrect mark if you type the wrong case. And this one here, state the value that were returned with a subroutine called code to char, char to code E plus 2. So let's start by just blanking out this section. Let's ignore that bit to start with. So let's do code to char E. So char to code, if we look at the thing here, turns a character into its ASCII equivalent. So in this case, I know that capital A equals 65, capital B equals 66, capital C equals 67, capital D equals 68, so therefore capital E equals 69. And then it says that plus 2. So if I add 2 to that, F is 70, and then capital G is 71. So that means that 71 is plus 2 is what I get. So we've done the char to code, and then what it's asking you to do is then turn that back into its character using code to char. So code to char of 71 is G. So the answer to this question is nice and simple. It's uppercase G. Okay, lowercase g there would not get you the mark. It has to be lowercase g. And there we go. So that is the explanation of ASCII and Unicode and how to answer those types of questions in the exam.